one, we're going to have a look at all the basic bits and pieces, all the things that everyone seems to forget. We're going to have a look at those nasty fractions. We're going to have a look at the addition, subtraction, that nasty long division that amazingly many of my A-level students can't do. Let's have a go and see what you remember. Now, the first thing I suppose that we do is let's have a go at simple addition and subtraction. How boring is this? We've got simple numbers and you've got to add up something like that. Right, so all you have to do for remembering there is to actually line up the tens and units, and then it's really easy. And addition is always the very easy one that we can do. So 5 and 2 is 7, 7 and 4 is 11, put down the 1, and then we remember to carry the 1 and we add it on. Easy. Subtraction isn't a real problem, except we've got all those nasty things we have to remember. So if we do, well, even perhaps the same sum, we look at, here we are, 345, but we take away 72, then it's quite easy. We can just take a number away from another number, that's no problem. That just leaves us with 3. But when we come to the 7, take away from the 4, we can't, and that's where we go through in many ways. There are lots of ways of doing this, but I learned borrowing, and I still find this is one of the simplest ways. And to say, well, what is here? This is 100. We're actually going to borrow 100 and put it into that column, so this is going to go down to a 2, and we put this one in this column, and then we can do the subtraction. We can do 7 from 14 leaves 7, and nothing from 2 leaves 2. So they are fairly easy things to do, and if we do this with decimals, it's just as easy. We've got 3.45, and we've got here plus 0.72. All we have to do for those is to remember that the decimal points line up to do our addition or our subtraction. When it comes to multiplication, this is not such a nice, easy problem, and there's lots of ways of doing this, but the basic way of doing this involves simply playing around and doing your tables. And if you don't know your tables, then this is going to be moderately difficult. So are there any ways of getting round this problem? Well, let's suppose you don't know one of your tables very well, and it typically is going to be something like the 7. You don't like the 7 times table. So there's nothing to stop you on a bit of the exam paper that you're not going to use writing out your 7 times table. And many people remember their 7 times table as going 7, well, I can add another 7, 14, I can add another one, 21, and we can work out what they are, and then perhaps you can write down this is 1, this is 2 times, this is 3, this is 4, and then, well, my problem is when I was at school we learnt these by rote, and it stayed with me my whole life. So when we do these, we don't need to worry about lining anything up. We just go through and we do this multiplication. So let's do it. 2 5s are 10. Put down the 0, the units, we carry the 1. And I just put it down there as a small number so I don't have to worry about it. 2 4s are 8, plus that 1 makes 9. 2 3s are 6. Now, when we come to multiply by a 10, then we start off in the tens column. So here are units, tens and hundreds. So we start off working in our tens column. 7 5s are, there we are, 35. And we can put our 3 down there. 7 4s are 28, and 3 makes 31. And then 7 3s are 21, and 3 make 24. And now we go through and we do the addition. And if my line takes those numbers out, it doesn't matter. So we get 0, 9 and 5, 14. 1 and 6, 7, and 1 is 8, 4, 2. And we've got our long multiplication done. Trying to do it the other way is generally much slower, and in an exam you're nearly always up against it, and in that case then it's going to give you some problems. Let's do the same sort of thing, but let's now do long division. And there's many people who've been taught sort of cheating ways of doing long division, but basically when it comes down to it, this way works as well as any other. Right, so I've got 72s into 3 4 5. Well, 72s won't go into 3, 72s won't in fact go into 34, so it's going to go into 3 4 5, and that's going to go, well, if I think about my 7 times table, 7 4s are 28, 7 5s are 35, that would be 350 in this case. I know there's 72, so it's going to be probably, it's going to go 4 times. So we put the 4 in here, and then I do 4 72s. I would do this on to the side on another bit of paper, and this is why I love doing long division, because it gives you practice to play with all the multiplication as well. So 4 2s are 8, 7 4s are 28, so it goes 288 times. I write it down rather than trying to do this in my head and trying to put the number up there and trying to remember it. It works just as well. So we can do this sum, and it's not really very difficult. It's just trying to do a simple takeaway. So 8 from 5, obviously I can't, so I'm going to have to borrow, and that's going to become a 3, and that becomes 15. So 8 from 15 is going to leave 7. Here I've got to do 8 from 3, I again can't, that becomes a 2, we borrow, and 8 from 13 leaves 5. So there's my little bit of sum there. There is here an implied decimal point. Let's make sure that the decimal points line up. And so here is a 0, and what we're going to do is we're going to bring that 0 down, and by doing that we can now do 72s into my next number, which is here 570. So if we're going to do this one, we've got to try and work out how many times it's going to go. 6 might be a likely number. We notice that 5 is going to make 35, so 6 7s, yeah, but we could go 7 7s are going to give me 49, yeah, 8 7s, so it could be 8 or it could be 7, I don't know. Let's go for 7. So 72 here times 7. Let's have a go. 2 sevens are 14, 7 sevens are 49, 1's 50. It's going to be close. I could check, but I can actually see that if I added another 72 on there, that's going to make 576. So it is actually going to go just the 7 times. So let's put my 7 there, and here we've got 504. Let's do the takeaway again, and again we're going to do that in the same way. So 4 from 10 leaves 6, nothing from 6 leaves 6, and so we've got 66. We've got another 0 here, and we can bring that down. Now, at what point are we going to stop and decide, well, for this one, let's suppose we look at just 2 decimal points. So we're going to look at 2 decimal places. 72 going to go in there. Well, 10 will be 720. We're not far off of that, so let's call that 9. So what I'm going to do is 72 times 9. So 2 9's 18. 7 9's are 63, and 1 is 64. We weren't far off. 6 4 8. That's going to go there my 9 times. And let's again do the takeaway. You're wondering what? Simply, I'm doing it again because I want to check on this one to check on how it's going to round. So we've got the same problem as before. So 8 from 10 leaves 2, 4 from 5 leaves 1, and then this is going to come down with my next 0 to be 120. 72's into 120, it'll go 1. It won't make 2 because that will be over 140, be 144. So it's going to be a 1. So my answer now is, in fact, that's not going to affect that number, so it's going to be 4.79 to 2 decimal places. So that's given me simple basic addition, subtraction, multiplication and division, and nearly everyone can do those, and there's no problems with doing those. What does cause the problem, of course, is when we have some fractions. And many times I've had classes and we do fractions and they go, oh yeah, I've done fractions before, yeah, I've forgotten how to do them. Yeah, they're those nasty things, aren't they? Do I work out the lowest common denominator, or do I cancel, or do I do that, leave it and switch and flip and... Ooh. Let's have a look. So let's have a look at some simple fractions. So let's choose something fairly easy to do. Let's do a simple addition of fractions. So let's have a go at 2 3/8 plus 1, and what should we go for? We don't have to make it too hard. 2/5. Now, if I'm doing addition, I can afford to get rid of all the whole numbers to start with. So that's going to give me 3, and I've got then 3 3/8 plus 2 over 5. And we just have to remember how we're going to do this. So we're going to find a number that both these go into. If you can't think of any other, then just multiply the 2 together. So this is going to give me 5/8 of 40. So they're both going to go into 40. Right, what have I done to the 8 to get 40? I've multiplied it by 5. So what I do to the bottom, I must do to the top. So we've multiplied the bottom by 5. Let's multiply the top by 5. 3 5s are 15. What have I done to the bottom to get 40? I've multiplied by 8. So let's multiply the top by 8. 2 8s are 16. So that's going to give us 3 plus, and now I want to add these two together. So 5 and 6 make 11. I need to carry my 1, 1 and 1, 2, plus 1, 3. So it gives me 31 over 40. I can look at that and I can see that 31 is a prime. It's not going to be actually worth doing anything else with, so I can now just say this is going to be 3 and 31 40ths. If we've got a subtraction, then it's done in exactly the same way. But there's usually a problem with this, and the problem comes when we try and do this. So let's do this one again, but this time we'll do 2 and 3/8, and I'm going to take away 1 and 2/5. Now we've got to look at these numbers and we've got to say, is 2/5 greater than 3/8? If you're not sure, well, just don't worry about it, and we'll do it the hard way. I'm going to convert this to an improper fraction. So 2 8s are 16, plus 3 makes 19 over 8, and I'm going to take away from that 5 times 1 is 5, and 2 makes 7 over 5. Okay, so what we've got to do is now do a subtraction. We'll make these the same denominator. I put them both under the same number. I don't write, as in this case, I wouldn't have written 15 40ths and plus 16 40ths. And the reason I don't do that is then people do silly things like they add the two 40s together. Whereas if I put them under here, I know they're over a common number and I don't have to deal with it. Right, what have I done to the 8 to get 40? Again, we multiplied by 5. So now I've got to do 19 by 5. Ugh, 19 by 5 I can't do. 20 by 5, well, that's not difficult. That would be 100. So if I take 5 away from that, that'll give me 19. So that's going to give me 95. Now, what have we done to the 5 to get 40? I've multiplied by 8. So we multiply the top. We do the same to the other one. 7 8s are 56. Now, you can either do this in your head, or if you can't do it in your head, then nobody's going to object if you do a little sum next door. 6 and 5 I can't, so I'm going to have to borrow. So now it is 6 from 15, which is going to leave us 9, and then 5 from 8 is going to give us 3. So now we've got my answer of 39 40ths. 39 will divide by 3, but 40 won't, so we're stuck with that one. And there, in fact, is our answer. Let's suppose, instead of that, we're asked to multiply. Well, the typical sort of ones that you're going to get are going to be nastier sort of things. But when you can do the multiplication of some of these, we can sort of find that there's easy ways of trying to do this. So let's have 2/15 times something like 5/8. When I want to try and do a sum like this, the first thing I want to do is see if I can make my life easier by doing some cancelling. So 2's into 2 go 1, 2's into 8 go 4, 5's into 5 go 1, and 5's into 15 go 3. And now all I've got to do is 1 1 is 1 and 3 4's are 12. And that way I have made my multiplication an awful lot easier. How about if we've got to do some awkward, horrible division? Well, these often work out in exactly the same way when we're trying to do them. It's not really a problem. But first, let's deal with a harder one that causes students some problems. Let's suppose I had 3/5, and I'm going to multiply that by 2/3, and I'm going to multiply that by, I don't know, something like 5/6. And at this point people start to panic and they say, oh no, look, I've got 3 numbers. What on earth do I do? Exactly the same, they'll cancel. The 5's cancel. I suppose here the 3's cancel. The 2 into 2 go 1, 2's into 6 go 3, and there I'm left with simply a third. 1 times 1 times 3 is 3, and 1 times 1 times 1 is 1. So we've got a simple multiplication that comes out, and it's not really a problem when we want to try and do this. Our problem normally comes when you're asked to do a simple division, and these simple divisions seem to cause students an awful lot of problems. So let's have a go at one of these. Let's have 28 over 33, and I'm going to divide that by something like I know, let's do 14 over 22. You probably wouldn't get that, but it'll work easily here. So we have to remember to leave this one alone, and then I'm going to switch the sign. So this is going to be 28 over 33 times by, and I flip the last number. Now this will cancel. We look at these and we see that 11's going to go into 33 3 times, and 11 will go into that 2 times. We can look at this and say that 7's will go into both numbers, 7's will go into 14, but then 14 will also do this. 14 goes into 14 once, 14 to 28 go 2, and that leaves me with 2 2's are 4, and 1 3 is 3, and we convert this to the proper fraction. 3's into 4 go 1, and there is 1/3 left over. So that's giving me all these fractions. What happens if we get something horrible? Let's suppose we get something like, let's go for 2/5 plus a half in brackets times by, let's do an easy one, let's just do 1/3 plus a quarter, and we'll put that one in brackets as well. We remember BIDMAS, or some people learnt BODMAS. Brackets, indices, division, multiplication, addition, subtraction, or brackets to the power of division, multiplication, addition, subtraction, the order in which we do things. So I've got brackets, so I've got to do those sums first. So let's do those. So I'm going to have this over 10, and what have I done to the 5 to get 10? I've multiplied it by 2, so I do 2 2's are 4. What have I done to the 2 to get 10? I multiplied by 5, so 1 5 is 5. And we can work out that these two are going to go into 12. What have I done to the 3 to get 12? Multiplied by 4, so that becomes 4. 1 times 4. And then what have I done to the 4 to get 12? Multiplied by 3, so I multiply the top by 3. 1 3 is 3. So let's do our additions. 4 and 5 make 9 over 10. Times by 4 and 3 make 7 over 12. It will cancel. 3's go into 9 3 times. 3's go into 12 4 times. There's nothing else on the top and bottom that's going to cancel. So now I've got to do my multiplication. 7 3's are 21 over 10 4's are 40. Now, will it cancel? And the answer here is, well, are there any numbers that are going to go in? 3's and 7's will make 21, but 3's and 7's won't go into 40, so it stays there. So there are our two nasty ones to have a go at, simply our fractions and our normal arithmetic to sort of try and cope with, remembering that decimals also have to sort of line up and do the things that they do. What other things come in? Well, typically in this sort of level we'll also have a few surds. So let's think of a few surds. So let's imagine we've got a simple surd, which is 1 over root 5, and as a scientist I'm happy with that. I don't see a problem with that. But mathematicians seem to like it round the other way, and they don't like to leave a surd at the bottom. And I do try and explain to some of them that if I want to do some work in science, that then I often need to turn it back into this form to use it. But they explain to me that it's sort of much better to have it that form, because I think it makes them happy. But anyway, we're going to try and keep people happy, so I want to get rid of this number at the bottom, and I can do that by multiplying both the top and bottom by the same thing. So we've got 1 root 5 times by root 5 over root 5. 1 times root 5 is root 5. Root 5 times root 5 is root 25. The square root of 25 is 5, so this gives me root 5 over 5. In fact, if we look at any of these that look like this, this simply becomes root 7 over 7. And after you can be sort of a standard sort of thing that you need to do, and you need to sometimes realize what a surd is. Sometimes you get a number and you think, well, can I express that as a simpler number? So let's have something like root 20. Can I make root 20 easier? Let's see that 20 is made up from two prime factors. It's made up from root 4 times root 5. And if I do this, this will give me the square root of 4 is 2. and root 5. I can even prove that quite easily, because these aren't done in a calculator paper. But if they were done in a calculator paper, and I wrote down something simple like root 20, and then I press from there the equal sign, and I've gone and lost my mouse. There it is. It gives me the 2 root 5. So surds come up really, they're quite simple to try and do, but the usual sort of problems that you get in this sort of basic maths, can you solve the problem, is where we've got perhaps 2 sorts of central heating plans. I've got the A1 care plan, and they have a fixed charge for doing my mending or whatever it's going to be, and then we get a sort of call out charge for everyone that we're going to try and do, or we might have the A2 every plan, and this might be just set at perhaps I don't know, let's go for £200 per year, and this will have a fixed monthly fee of, let's say, £10, and a call out charge of, let's say, £80. But this one here might have a call out charge of, let's say, £40. Now let's presume that you have to make sort of 2 call outs a year. Which one's going to be the cheapest? So we're going to do 2 call outs. So this one's going to cost me 200 plus 80, and this one is going to cost me £10 fixed per month, that was. So that's going to be £120, and then 2 call outs are going to give me £160, which is going to give me £280. They cost me exactly the same. But typically when they do this, they would actually say, yeah, but how about for 3 call outs? Well, for 3 call outs, this is going to come out at £320, whereas this one is going to come out at £360. So here it's going to depend on what you're going to try and do, and you take a gamble, I suppose, on some of these when we try and work out what's going to happen. Where we get lots of other things with basic maths is, well, we get thrown into these things. Circles. What are circles going to give us? Well, we've got to remember to work out our perimeters. Now, I know the perimeter of a circle is called the circumference, but usually when they do these, they make it nasty. And to work out the circumference is going to be either pi times the diameter, or it's often written as 2 times pi times the radius, or you could write it as pi 2r. 2 pi r is the way I learnt that. So let's be given a simple number, and in this simple number, as he knocks everything over, we're going to be given a simple radius. So let's have a radius here of 5. In a non-calculator paper, they'll often say leave in terms of pi. So this would simply be 2 pi r, which is r is going to be 5 times 2, which is going to give me 10 pi. If we're going to have to work out something grotty, then they might give us something a bit more difficult to do, and let's go for something that's not really that difficult, and we'll go for here, what is the perimeter of this semicircle? Well, we'll be told that this number here is a radius of 5. Again, we'll do the same numbers, so I can work out the circumference of the circle, but I haven't got the whole circumference of the circle. I've only got half of that, so that's going to be again 2 times pi times 5. Put the times is in there, but I only want half. They're going to cancel, so it's going to give me 5 pi, and then I want to add on this distance at the bottom, which is going to be 10. And so I go to my calculator and I can work this one out. If it's on a calculator paper, then this would simply be 5 times pi, which here on this calculator is down on this button, 5 times pi, and then I'm going to add on 10. The calculator understands BIDMAS and it gives me my answer, and there I've got my answer of 25.7. If I'm asked to work out other things such as areas, then this is not that difficult again. So let's have my circle, and with this circle let's have this time let's go for a diameter of 8, and to work out the area of a circle, it is simply going to be pi r squared. So I've got to take my diameter, which is 8, that's going to give me my radius is going to be this time 4, so this is going to be pi times 4 squared, which is going to give me 16 pi. If I've got to try and work out things, then you have to try and work out awkward sort of little sums, and sometimes you've got to look at your basic shapes and see what's going on. I've seen various nasty problems in exams where they give you peculiar sort of shapes, where they might give you shapes like these and get you to work out all sorts of peculiar bits and pieces, and what you have to do is keep your wits about you to work out how long different things are. One of the ones that comes up often is this problem where we've got 3 balls. This is for playing around with sort of a tennis set or something, and we've got 3 balls in a tube. Let's just draw my little tube in here, and I've got my little tube, and it said whether each of these is a sphere and what is the space left behind. Well, if we've got one of these, they say, well, each ball we've got here has a radius, let's say, of, I don't know, let's go for 3 centimeters. What can we work out? Well, if we know the radius is 3, then the diameter is going to be 6, and that's going to be 6, and that's going to be 6, so this is going to have a height of 18 centimeters. And if it fits the balls here exactly, then it's going to have a diameter here of 6 centimeters to work out this tube, because that's what we're talking about. This is some sort of tube. Then we work out the area at the bottom, which is going to be pi r squared, so that's going to be pi times 3 squared, which is going to give me 9 pi. I can work that out anytime I want to on the calculator, and I'm going to multiply that by the height, so the volume of this cylinder is going to be simply the cross-sectional area, 9 pi, times the height. So that's going to be 9 pi times a height of 18. So all we have to do is multiply 9 by 18, which is 162 pi. If it's a problem like this and you've given it in a non-calculator paper, then everything's expressed in terms of pi. If it's in a calculator paper, then you've got your calculator to work it out. Now all I need to do is work out the volume of each of these spheres, and here we've got 4/3 pi r cubed, and that helps us work out the volume of a simple sphere. So this is going to be 4/3 times pi times the radius, which is 3 cubed. Now 3 cubed divided by 3 is in fact the same as 3 squared, and 3 squared is 9. And then all we've got to do is work out what 9 fours are. So that's going to give me 36 pi, and that equals 1 ball. I don't have 1 ball, I've got 3 balls. So I would need to multiply that by 3. So easy enough. Just come back to our basic maths again. 6 3s are 18, 3 3s are 9, and 1 is 10. 108. And now to work out the difference, I've got 108 pi there. I've got my number 162 pi. I can take away my 108 pi, and we can simply work this one out. So 8 from 2, again I can't do that, so let's do this borrowing. 8 from 12 leaves 4, nothing from 5 leaves 5, so that's going to give me 54 pi. And then if this is a calculator paper, only then will I now bother go over to my calculator and work out what is 54 times pi. And my calculator is very friendly and it tells me it's 54 pi. But if I do my third to decimal, I've got my number, which in this case is 169.64, and if I'm doing it to just perhaps one decimal place, then that was going to give me 169.6 centimetre cubed. We've looked at a whole series there. We can look at all types of problems with circles, volumes. The ones that are difficult are the ones that are generally so simple. For instance, we're asked to work out the area of a triangle, and students sort of panic about this and they say, oh, I can't do that. Working out the area of a triangle is just sort of, well, too difficult. But they don't have to be too difficult. Let's just take here a triangle, and this triangle that I've got, people say, oh look, I've got no height. I've got to work out the height of a triangle, because we know that's the half times the base times the height, and perhaps I don't know the height. Well, often you can then drop a perpendicular down, and then using things like Pythagoras, you can work out your height of your triangle. Sometimes they make life easier for you, and you have to keep your wits about you, because what they might give you is a triangle which is possibly a right angled triangle, and they just give you this measurement and maybe that measurement. And the other one you have to recognize is your Pythagorean triples. That if I've got one side that's 3 and the other side that's 4, then in a right angled triangle this is 5. And if I have a relationship on the same thing, so let's go for another triangle which is the same shape, and this time this is a 6 and an 8, we can see that this is doubled that and that's doubled that, so this side must be double that. And we can get lots of these different Pythagorean triples. There is one other that comes up quite often, and that's this one that's 13, this side that's 12, and this side that's 5. So knowing these can really help you try and get some of these simple bits of maths, because this sort of simple maths comes up over and over again in basic GCSE papers. They're after all the time getting you to work out and remember simple things like volumes, areas, work out how many of these shapes. The number of times I've seen a problem where a student's stuck simply because they're given something like this, and this represents a little house, and I don't really want those extra little bits, that's just my lousy drawing. And they'll be given that number, and they'll be given perhaps this number, and they might be given that number, and they have to try and say, well, I don't know anything to work this one out. Yes, you do. You do know lots more than you're being told. We know the volume of this easy simply by multiplying the two together. But what have we got here? Well, I've got a triangle, and this triangle here has this length of 5, this length is 4, and you go, well, it's a non-calculator paper. Yeah, but you can work out that that one is also 3, and once you've worked out the height, then you can work out the area of this triangle, and you can then double it. So this is going to be 6, 3 fours are 12, times a half, which is going to give us 6, and I've got 2 of them, so in fact the area up here is going to be 12, which gives us the total area of 12 plus 48. Centimeters, maybe it's probably meters if it's a house, but we can get this sort of basic sort of ideas to try and remember and work out. Related to this problem is the other one where you're asked to try and think about simple maths. The idea that we've got some shape which is cut out, and if this is cut out, then we either drop a perpendicular one way or we go the other way, so that we can work out the size of these different shapes and work them out. I saw a question that one of my students had to do recently, and he was given peculiar shape and he had to try and work out what this was, and he was given this particular shape and he was told everything about it, but then he was given it probably something like this, and this is a multiple shape, and I'm not bothering to draw all the multiple shape, but if he was given some of these numbers, then he could work out what the other number was, and then he could take this amount away from this one. He could find out the numbers that he had to try and work out. So he got all the things that he needed, but he couldn't see this length. And that's the sort of thing that you've got to try and spot in exam questions.
This is a reminder. Take a Pythagorean tablets.
So that gives us an idea about, hopefully, lots of different shapes, simple things in maths. The last thing to basically remember is that if I'm given a shape, but this time it's made 3D, then working these things out is simply by working out the cross-sectional area and you multiply that by the depth. And it's just keeping your wits about you, because someone's trying to make your life a little bit more difficult. They're trying to get you to think about problems that you will meet with simple arithmetic, be it surds, fractions, decimals, or ordinary numbers. And once we've got the idea of these, then a lot of the maths is quite easy. So you just have to remember your shapes and those simple things, and going through the GCSE is a breeze. Well, I hope you found some of this useful. If you liked it, then you can always give me the thumbs up, and please subscribe, and I will see you next week when we'll have a look at some more GCSE maths, going through topic by topic. Until then, stay safe. Bye bye.